Hello, my name is Ben. I'm a PhD student at Northeastern University, and I'd like to tell you about a language I've been working on called Shallow Typed Racket. Shallow is an alternative to normal deep typed racket, and the pitch is that shallow gives you the same types but weaker, and I'll explain why that's a good thing. So first, same types means the same language of static types and the same type checker. If you've taken untyped code and added annotations to it to get a well-typed deep program, then you can use exactly the same annotations. Just switch the hash line at the top, and now you have a well-typed shallow program. And then in the other direction, if you have typed code that currently fails to type check, then switching that over to shallow is also going to be a type error. So these two are using exactly the same type checking code. The differences come about when we run the program, and in particular when we have typed code that talks with untyped. So on the left here we have a deep type function, makeRandomList, that promises a list of strings. And on the right we have an untyped REPL that calls this function a few times. So what can come out? We could get back an empty list. We could get back a list where that's not empty, where every element is also a string. And another big possibility is we could get a contract error. So this third thing could happen if deep on the left talks with another untyped module. If something goes wrong with those communications, maybe deep expected one type but untyped gave it something else, then we would see a contract error like this saying, I couldn't give you a list because something else went wrong while I was trying to make it. Now if we switch to shallow types and we have the same promise, list of strings, we could get back the same results. We could get back a list where every element is a string, and we could also get one of these contract errors in case the shallow code talks to untyped code and something goes wrong with their communication. But other things can happen now too. We could get a list that has numbers and symbols or other lists. So the promise list of string turns into a guarantee that we have a list over an untyped, but then nothing deeper about what are the elements of the list. Here's a second example. Deep code promises a function that computes a string. If we call this over an untyped, if we get a value back, we can be sure that it's a function. And if we call the function, we can be sure we either get a string or we get one of these communication errors. So suppose our random function talks to untyped and it tries to throw an integer back. And then the deep types will catch that mistake. They'll say, hey, I promised a string, but something else tried to come out here, so I'm going to stop the program and something went wrong. You need to diagnose. If we switch to shallow types, now our makeRandom function promises a function that computes a string, but when we call it a few times, we get back totally different results. We might get a string, but we also might get a number or anything else. So what's happening is the promise function that computes a string turns into a promise that we have a function over an untyped. But then beyond that, there's no promise about what that function computes. Hang on though. If instead of untyped, we call from shallow, and then our random function tries to give us a number and the shallow types expect a string, in that case we would see one of these communication errors, where the shallow REPL on the right would say, I was looking for a string but I got something that didn't match. So what's going on here in general? If deep promises a full type, it's going to enforce the full type when you run the program. So yeah, anytime a value gets matched up with a type, and that could be either through type checking or when the program runs and the untyped value crosses a boundary, then that type is a guarantee about how the value is going to behave. If anything happens with the value where it doesn't match up exactly what the type specified, you'll get one of these contract errors. The shallow promise is much weaker, and it guarantees that things look correct in typed code, but then nothing more than that. So inside shallow type checked code, every value is going to have the right top level shape. But then outside, when things float to untyped or anywhere else, all bets are off with shallow. It doesn't care. If the value comes back in, then shallow is going to have more checks. But until then, it has nothing to say. So from these two promises, we can implement shallow and deep using two different ideas. And thank you to Sam Tobin-Hochstadt and Michael Batusik for the two semantics that are really under the hood here. Sam's natural semantics for deep, and Michael's transient semantics for shallow. So here's a sketch of those two semantics. Deep looks at every boundary. Where could things possibly go out to non-deep code, whether it be shallow or whether it be untyped? At those boundaries, deep takes the full type and puts in a full higher order contract. Whatever it needs to enforce the type at runtime is going to sit there at the boundary. With shallow, the strategy is take every expression inside typed code, and if that pulls a value out of some data structure, or some interaction happens where we get something out that came from untyped, shallow puts a quick shape check inside there to say, does the outermost part of the value that I just got match the thing that I'm expecting? Okay, so shallow has potentially very big checks only at the boundaries, and then shallow has little checks spread all throughout your typed code. So with these two different pictures of the implementation in mind, I can tell you about the main attraction of shallow typed racket. And it's that we can do this gradual typing, this typed-untyped mix, with no chaperones, no higher order contracts to get in the way. And right off the bat, this gives us some big benefits. Faster boundaries, can express more combinations, and it's a simpler behavior. So deep types can be slow, and shallow types can lead to faster boundaries. Here's an example. We have a small program with two modules that computes prime numbers for us. When both modules are untyped, running the program takes about 2 seconds. If we switch one of the modules to be deep typed, then the same program and the same result takes 13 seconds to come out. If we switch from deep to shallow types, then running the program takes about 4 seconds. So what we're seeing here is the cost of the boundary between deep and untyped versus the cost of those shape checks in shallow code. In this case, the shape checks are a lot cheaper than the contract enforcement. And yes, it's similar in other benchmarks. So here's just a few that we've been using to measure performance. The left column of this table is the names of different benchmarks. The middle column is the worst case we saw with worst case overhead of deep types. And then the right column is the worst case overhead of shallow types. And in both cases, we're talking about overhead relative to the untyped program. So with deep, things can be pretty bad. Depending on how you've mixed typed code and untyped code, and depending on the boundaries that are sitting there, it could be 400 times slower or 14,000 times slower. And yeah, it's not good. I mean, we hope to improve deep over time, and it's made a lot of progress, but today there are still slow things. Shallow, on the other hand, gives us better performance today, right now. So the worst case out of all the ways of mixing typed and untyped in shallow, for these benchmarks, it winds up at 8x. We've seen things that are slightly slower, but nothing close to 14,000, nothing close to 100x either. So shallow can be a lot better depending on the boundaries that you have. On to the second benefit, deep types can be picky, and this can lead to some confusing behaviors. So sometimes you see questions like this on the mailing list. Help, I have a program that I thought should work, but I try to run it and Typed Racket gives me this error. Yeah, so what's going on? Here's a small program that has the same behavior. On the left, deep code creates a box, gives the box the any type, and then sends it across a boundary to untyped. Then on the right, the untyped code just tries to put a new value inside the box. And the error that we get says, you attempted to use a higher order value that was passed as type any, and I'm going to stop you. That's deep's opinion. There's a good technical reason for this. So if our deep code was a little bit bigger, and if it later on tried to read something out of the box, and untyped code had put something bad inside in the meantime, then you could wind up at a bad situation. That doesn't happen in this program, and that's why the error is so confusing. But that's why this error occurs. With shallow, though, there's no problem. Shallow code can send out a box with type any, and untyped code can write whatever value it likes inside that, and it's all fine. So this program just works. If the shallow code was bigger, and we got to that tricky situation where untyped code put something bad inside the box, and shallow tried to read it out later on, then there's going to be a shape check right around that read, and that'll protect shallow from going off the rails. So the shallow is still safe, and it's more permissive. Then, onto the third benefit, deep types can change the behavior of some programs. So first of all, index of is a list function. If we give it the list AB, and the value A is the second argument, it'll give back 0, saying, hey, I found that A as the first element, or position 0, inside of the list. Great. If we switch over to deep types, then we need to give a type to index of. So And the right thing to do is give it a precise polymorphic type that says exactly what index of is doing. If we use that type, though, and we run the same program, we ask, where's A inside the list AB? It says it's not found. False. There's no value inside here that matches. And the reason for this mix-up is that wrapper that forces the contract. So to make sure that the polymorphic type is a correct description of the behavior of the index of, deep has to insert wrappers. And because of the wrappers, the equality comparison gets thrown off. So that's why our index of can't find the element anymore. With shallow types, that goes away. There's no wrapper, so there's nothing to get in the way of the comparison, and the behavior we have is the same as we'd expect from untyped. Okay, so these are some terrific benefits. But before you get too excited, let me tell you about some of the limitations and drawbacks of shallow. So before you get too excited and sign up, let me tell you why the deep needs to stay around. And in the end, we really need this combination of deep and shallow to be in the best world. So shallow types can be slow. Here's our prime number program where every module is typed. If we use deep types, then there's no cost to the boundaries, and the type optimizer kicks in, so we run even faster than we were when we were untyped. When everything's shallow typed, the optimizer still runs, but the cost of those shape checks weighs things down, so we wind up at 5 seconds, which is a little bit slower than when we mixed shallow and untyped. So in this case, a fully typed program is better off than deep, and then we've seen this borne out in other benchmarks as well. So in this table, the middle column is what's the overhead of fully typed deep versus untyped, and on the right column we say what's the overhead of fully typed shallow versus untyped. Fully typed deep is usually on par. We typically see 1x, but sometimes it's even faster than untyped because of those optimizations. The exception in this table is MBTA, and that still has some overhead because our fully typed user code still talks to an untyped library. So there's some overhead there that the MBTA author has no control over. But those middle column results are always on par or better than the shallow results we see. So when you have more typed code on the right in shallow, you just pay more cost. Again, the cost isn't as bad as boundaries can be inside deep, but shallow fully typed is not as good as deep fully typed. Then the second big drawback is this idea that shallow types are temporary. Once the value goes off to untyped code, shallow's hands are off too. So we saw a small example of that with this make random function, where with untyped, shallow will miss the mismatch between the typed string and the value that comes out. But if we use typed code instead, it would catch it. So in a bigger program, this can lead to some confusions. You might see a weird result coming out of your code, and you might see an error coming way later along the lines because some mixed type communication went badly earlier on. So if you're trying to debug, I recommend switching back to deep, because then you can fully trust the types that you're reading. Whereas in shallow, you have to just skin deep, and that's really all you can rely on. Right, shallow typed racket, no chaperones, no higher order contracts. Leads to some great benefits, but it also has some drawbacks. So with that in mind, I want to conclude with some recommendations for when do we use shallow and when do we use deep, now that we have this 3-point design space. So if you have a specific error that you're trying to get around, or that you don't understand, use shallow types. And then if you have some boundaries that are having a high cost in slowing your program down, also switch to shallow, because the typed untyped boundaries should, the cost of these is much, much less with the shallow strategy. Then on the other hand, if you know that you want the full strength of the types, or if you have a fully typed program, then you're probably better off using deep. In general, I would say, as a migration path, if you're going from untyped and adding types to it, start with the shallow types. I think shallow is going to be a lot easier to use, with fewer errors and more expressiveness. And then, once you've figured out what types you want, and also, once you've figured out what boundaries you're going to end up with, of where your now typed code still talks to untyped, then you can think about adding the full strength of deep types. So yeah, add deep where you decide that you want the guarantees, and stick to shallow if there's going to be a lot of back and forth between untyped. And I'll be excited to see going forward, what combinations work out in practice. I have a few specific examples where you really want the mix of shallow and deep, but I'm looking forward to seeing a lot more. Okay, so that's the talk. Shallow is coming soon, I hope early 2021, and you can follow along at the RFC document and the pull request on the slide here. The end. If you have any questions, you can leave them in the comments below, and I'll try to get back. And I'll also link to an early version of this talk that appeared at Racket Con last weekend. So there was a Q&A after that talk, and it might be that your question was already answered inside that. But until then, that's all I have to say. So goodbye and happy coding.